In this lesson, we look at distance from great circles. Because from our previous class, we discussed what a great circle is. We said that it's a circle whose radius is equal to the radius of the Earth itself. So based on that, we learned that all the lines of longitude are great circles. The lines of longitude which run from north to the south pole, they are all great circles. If latitude, on the other hand, only the equator is a great circle. So how can we determine distances on great circles? That is, distances on lines of longitude or on the equator. Let me read from what I have here in my outline. You see, we stated earlier that the lines of longitude or the meridians and the line of latitude, parallel of latitude, are used to locate the position of places on the surface of the Earth. And we do that by drawing the latitude in question. So if I have this to be my globe, this is my meridian, this is my equator. Now let's assume I have a location or a point that is located on this latitude. Assuming this is latitude 31 degrees north, then I have that same point in terms of the longitude now, maybe 18 degrees west, where the line of latitude and the longitude meet is the location of that point. Perhaps I have another point which is on longitude, maybe 20 degrees east. How can I determine the position or the distance rather between the two of them? The distance is this length of arc here. So the question is it on a small circle or is it on a great circle? In this case, this is on a small circle since the two of them now are on the same latitude, and that latitude happens to be a small circle. Remember that it's only the equator that is a great circle when we talk about latitude. The distance on this between these 2 points is on a small circle. It will be on a great circle. Let's assume I have another point that is located at, say, let's assume this is 25 degrees south. This is the point. Now, distance between this point and this point now is on great circle because it's on this line of longitude. It's on line of longitude. So the point I'm trying to make now, if the two positions you want to determine their distance, if both of them are on the same longitude, then that is distance on a great circle. If they are on the equator, it's also distance on a great circle. On the other hand, if they are in any other latitude apart from the equator, they are on a small circle. So let me read from the book. It said, just added that the location of such a place is determined by the point of intersection of the lines of longitude and latitude. That is, where latitude and longitude meet, give you the location of a place. Therefore, if there are two places on different locations on the Earth's surface, their distance apart can be calculated. Such distance apart can either be on great circle or small circle. For a distance to be on a great circle, the two positions connecting the distance must either be on the equator or on the same longitude, either west or east, but on different longitude or latitude as the case may be. So if they are on the same longitude, it's a distance on the great circle. If they are on different, what's it called? If they are on a latitude, apart from the equator, their distance on a small circle. In this figure, point P is on latitude theta 2 north. Look at it. Theta 2 north, but longitude theta 3 east. This longitude here. While point Q is on latitude theta 1 south, Where is it? Latitude theta 1 south. Look at it here. But longitude theta 3 south. And see both of them are on the same longitude. So if you are to calculate the distance between point P and point Q, that is distance on a great circle is on a longitude, the same longitude. This is the distance. This arc here form the distance between the 2 point P and Q. Since both P and Q are on the same longitude, theta 3 east, and different latitude theta 2 north and theta 1 south respectively, the distance between them lies on a gray circle. In calculating the distance along gray circle, what is required is to calculate the length of the arc, this arc length here. This arc length, let me put a mark on a highlighter on it. This arc length here is the distance between point P and point Q. And we can get that from our knowledge of the length of arc of a circle, which is given by length of arc is theta over 360 times 2 pi r. In this case, I'll use capital R, the radius of the Earth. So it's a great circle, distance on a great circle. So since both P and Q are on the same longitude theta 3 east and different latitude theta 2 north and theta 1 south respectively, the distance between them lies on a great circle. In calculating the distance along great circle, what is required is to calculate the length of an arc on the sphere of radius r, which is the radius of the Earth. So let's take some example. As usual, I don't need to read all of that. It's what we have been doing all along, right? Locating the position on the globe using the lines of latitude and longitude. Where the line meets, give us the position. They will find the latitudinal difference or longitudinal difference as the case may be. So the first example here says, find the distance between A, which is on latitude 56 degrees south, longitude 80 degrees east, and B, latitude 65 degrees north and longitude 80 degrees east. Take phi to be 3.142 and R to be 6,400 kilometers. So you draw your sphere. Draw your prime meridian. Draw the equator. This is a must to do because they are the reference point. Okay. Now A is on latitude 53 degrees south. South to be below the equator. 53 degrees south. For longitude 80 degrees east. 80 degrees should be close to, should be at the middle since this is 180 about. This is 80 degree east. Then point, well, point, that is point A. Where the latitude and the longitude meet, give you the point in question point. I say A and I wrote B, point A. Point B on the other hand is on latitude 65 degrees north. 65 degree north, longitude 80 degrees east, the same longitude 80 degrees east. So this is point B. Where the 2 points, where the latitude and the longitude meet, give you point B. Then to get the distance between point A and B, you need to get the angular distance between them first, this angle here. And remember that when the latitude are in different locations, we add the latitude to get the angle between the 2 points. So the latitude of this is 65, this angle here is 65, while this angle here is 53. Therefore, theta here will be 65 plus 53, which is 353 or 56. Can you imagine? This is supposed to be 56. I wrote 53. 56, not 20. This 56. I wonder where I got 3. Then plus 56. I think I did not make any mistake. 56, 56. 65, 65. Then longitude 80 meters. Okay. Now 5 plus 6 is 11. Right 1 carry 1. 5 plus 6 again 11 plus 1. 12. So the angular distance between them is 1 to 1. Theta is 1 to 1. Therefore, distance between AB, which is length of arc AB, distance between AB is length of this arc here, this arc length, and from our knowledge of circle, the length of arc is theta over 360 times 2 pi r, capital R, the radius of the earth. That will be 121 over 360 times 2 times pi. So if you use this value, 3.142 for pi, 142 times 6,400. By the time we put all of that into a calculator, we have 10517. So our answer is 13,517.58 kilometers. So that is that for question 1. And let's move on to example 2. Okay, we'll move on to example 2, which says 2 points P and Q. P is on latitude 32 degree north, longitude 47 degree west, while Q is on latitude 59 degrees south, longitude 47 degree west, are on the Earth's surface. If it takes an aircraft 14 hours to fly from P to Q, calculate its speed correct to the nearest kilometer per hour. Take the radius of the Earth to be 6,400 kilometers and pi to be 22/7. First of all, let's represent the information on the globe. The Earth is my sphere wonder. I'm going to use it like this is my prime meridian. This is my equator. It's too low. This is the equator, which is at 0 degrees. Then point P is 32 degrees north. North is above the equator. 32 degrees north. But longitude 47 degrees west. 47 degrees west. 47 degrees west. Where the latitude and the longitude meet, give us point P. So here is point P. Q on the other hand is 59 degrees south. South is below the equator. This is 59 degrees south. And the longitude is also 47 degrees west. So this is the longitude, 47 degrees west. So this is the point Q. Now the distance between P and Q, this line here, this arc, we need to get the angle between them. This angle, sorry, let me try it like this angle and this angle, which is theta. How do we get that? The latitude are in different locations, so the angle between these 2 points will be the addition of the 2 latitudes. Recall from our previous class, when the latitude are in different locations, we add. When they are in the same location, we subtract. So theta here is equal to 32 plus 59. I get that. And 32 plus 59 is 91 degrees. That is 2 plus 9 is 11. Carry 1 to this, that is 6, and this 91 is correct. And the distance between P and Q is this arc. From our knowledge of circle, we know that the length of arc, so let me call it distance PQ, distance PQ, which is theta over 360 Length of arc is 2 theta over 360 times 2 pi r. We're using capital R here because it's the radius of the Earth, this distance on a great circle. So that would be 91 over 360 times 2 times 22 over 7 times 6,400, radius of the Earth, which is here. So putting all of this in the calculator, we have 91 times 2 times 22 times 6,400. That is 256256. Let me write it down. 25625600 over 360 times 7 is 2520. 2520. So this, let's confirm that. 360 times 7. Good. So now let's divide 25625600 divided by 2520. 10,168. 10,168.888. Let me round it up to 89 kilometers. That is the distance between point P and point Q. But the question asks us to calculate the speed, right? Yes. Calculate the speed of the aircraft correct to the nearest kilometer per hour. So we know the distance between point P and Q, where the aircraft is flying from. It's flying from point P to point Q, a distance of 10,168.89. The speed of the aircraft, speed is distance over time. Speed is equal to distance over time. The distance as calculated is 10,168.89. The time is given in the question, 14 hours. So divided by 14 hours. Let's do the division right away. 10,168. 10,168.89 divided by 14. 726.35. And the speed of the aircraft is 726 point. What was that? They round it up. That will be 726 kilometer per hour, approximately. See, an aircraft leaves time X, a time X, which is on latitude 26 degrees north, longitude 63 degrees east, and after flying 3,900 kilometers due south, it gets to another town Y, calculate A, the radius of the line of latitude through X, B, the latitude of Y, correct the nearest degree, and C, the radius of the line, use line, not long, line of latitude through Y. First of all, let's represent this information in the globe, putting out the latitude and the longitude in question. Okay, this is the sphere. And draw the prime meridian, the equator. Okay. Point X is on latitude 26 degrees north. We may assume 26 degrees somewhere here. degree north. Longitude 66 degree east. Let's assume that is 66 degree east. Where the line of latitude and longitude meet, give us point X. Point X. Excuse me. Now, said an aircraft lift an X and after flying 3,900 kilometers due south, it gets to another town. Why? Due south, then it gets to another town. But in this case, we don't know the latitude. So I'm going to use a dotted line. For the angular distance, let me represent the angular distance here, which is the latitude itself, 26 degrees. Let me draw that properly. First of all, let's represent the angular distance here, which is 26 degrees, the latitude itself. But the other latitude, we don't know it. And this plane is flying along the same line of longitude, distance along great circle. So we're going to use a dotted line to represent the other latitude. And then the angle, which is the latitude itself, since we don't know it, let's just put alpha there. Don't know the alpha. But we know the length of this arc, this distance here. We know it. So length of arc or distance, xy, the other term is y. Distance sy is equal to the length of the arc, and length of arc is theta over 360 times 2 pi r. And since we know this distance, which is 3,900 from the question, 3,900 is equal to theta. We don't know. Theta is this 26 degree plus alpha. So let me just put it there. 26 plus alpha over 360 times 2 times 22 over 7 times 6,400 radius of the earth. So 3,900 is equal to 2 times 22 is 44. 44 times 6,400. 44 times 6,400. 281,600. There is now 281,600 multiplied by this 26 plus alpha all over 3. Okay, 360 times 7 is 2,520. Let's confirm that. 360 times 7, 2,520. So cross multiplying. This is over 1. So that we have the whole of this. When I multiply by 1, it still remains at that. So I have 281,600 multiplied by 26 plus alpha equal to 3,900 multiplied by 2,520. This multiplied by 26, 81,600 multiplied by 26, 73,216,00, and plus this multiplied by this is 281,600 alpha equal to, and this multiplied by this first student, and 3,900 multiplied by 2,520 20. That's 982,8,000. A collecting lifetimes. We have 281,600 alpha equal to 982,8,000 minus 732,1,600. 982,8,000 minus 732,1,600 equal to uh, 281,600 alpha equal to 256,400. So alpha will be 250,6,400 divided by 281,600. If 250,6,400 divided by 281,600, 8.9. So alpha is 8.9. Alpha is 8.9 degrees. Let's go back to our drawing. Drawing say the question rather say find the radius of the line of latitude through x. I also omitted question here. The radius of the line of latitude through s. Let me solve that first before we go on to that. Lines of latitude, radius of line of this question A here. Radius of line of latitude through A is r equal to capital R, the radius of the earth, cos alpha. So the radius of the line of latitude through S. The latitude of S is 26. So that will be 6,400, the radius of the earth, capital R, cos 26. Cos 26. Now what is cos 26? Cos 26 is 0.8988. Then this will be 6,400 times 0.8988, which gives us 5752.32 kilometers. And D, the latitude of y correct to the nearest degree. Our calculation will go 8.9, so correct to the nearest degree will be 9 degrees. Correct to the nearest degree. Okay, that is B. Then C, where does C say the radius of the line of latitude through Y? Radius of the line of latitude through Y. We know the latitude of Y, which is 9 degrees. So the radius will be capital R, the radius of the earth, then cos 9, which is 6,400 cos 9. Is cos alpha. Let me put alpha there. And cos 9 is 0.9880. So this will be 6,400 multiplied by 0.9880, which gives us 63 rather. 6323.2 kilometers. And the radius from that latitude is 6,323 longitude.